Welcome to our second lesson. But before we go on to our second lesson, we need to look at the previous lesson recap, where we looked into real numbers and we defined what real numbers are, and of course we gave some examples. And at the end of our lesson, we posed a question, and on this lesson, before we move on, we are going to give you a hint. Right, so if you had chosen numbers without letters, you got it right. So that depends on how the real number was written previously. So this can be further labeled as either rational, irrational, or integer or natural, of which that's what we are going to look at today. So when we are looking at our second lesson, we will look at natural numbers. Of course, you have to ask yourself, what is a natural number? So the first type of numbers that are learned about are the numbers that are used for counting, and these numbers are called natural numbers, and they are the simplest numbers in mathematics, and normally we use the letter n as a symbol to represent them. So generally, when we are talking about counting numbers, we are talking about numbers that start the count from 1, 2, 3, 4. Of course, we can have other numbers there. We can have the number 11, we can have number 12, we can have number 13. So all counting numbers are called natural numbers. We have another type of numbers called the integers. So what are integers? So integers are positive and negative whole numbers, and mathematicians use the symbol z to mean the set of all integers. The integers are a subset of real numbers, since every integer is a real number. So this simply means that since integers possess positive and negative numbers, so they are a subset of real numbers. Remember, on our previous lesson we spoke about real numbers, and we said real numbers are negative and positive numbers, though they also possess some fractions and other types of numbers. So integers are a subset of real numbers. So let's look at an example of integers. We've got numbers from -4, -3, -2, -1, 0, 1, 2, 3, 4. So all these whole numbers represent integers. Let us look at rational numbers. So suppose you are given natural numbers and integers, and you understand that these describe quantities that are whole or complete. So basically, natural numbers and integers are whole numbers. For example, you can have 4 apples, but what happens when you divide one apple into 4 equal parts and share it among your friends? So that simply means that that particular apple that you have divided into 4 equal parts is no longer whole anymore, and a different type of a number is needed to describe the apples. So this type of a number is known as a rational number. So a rational number is any number which can be written as a over b, where a and b are integers and b is not equal to 0, because if b is equal to 0, that simply means that we've got an undefined number or fraction. So we have an example below of rational numbers. We have 7 over 3, we have -1 over 2, we have 40 over 10, we have 5 over 20, we have 10 over 1. So you can see that they are all written in form of A over B, and that simply means these are rational numbers. So they simply give you or they simply define quantities that are not complete or whole. It's either they have been divided somehow. So when dealing with these rational numbers, you'll notice that mathematicians use the symbol Q to mean the set of all rational numbers. A rational number may be a proper or improper fraction. So I have a list below, and I want you to identify rational numbers in the space below. Okay, now you can try this activity on rational and irrational numbers. So I've given you a list of numbers below that I want you to identify, or that I want you to identify rather, rational numbers. Okay, so let me give you an example on how you can determine whether the number is rational or irrational. You can notice that you are given 0.5. So from the previous question, you are required to identify a rational number. Remember, we have given you examples of rational numbers, and most of these rational numbers actually give you an exact figure when they are divided. So you can turn this decimal number into a fraction. So 0.5 is equivalent to a half. So since I've shown you, or I've given you a hint, try to determine whether 0.5 or half is rational. Then we have 37 over 10. So that's another example, right? So I'm going to give you a hint as well. So you can divide 37 by 10 and you get 3.7. So does this fit into a rational number definition, or it fits under irrational numbers? Then we have 2, which can be written as 2 over 1. We know that all whole numbers are over 1. So the big question is this rational or irrational? Then of course the last question that I would want to look into is root 3. So if you punch your calculator, this is the figure that you get. So for most calculators, you realize that they are 10-digit calculators. So these dots simply mean that the list goes on and on and on, or it goes up to infinity. So the question is, these rational numbers as well, or they are irrational? See you on the next lesson. So for more questions, look into our LMS platform.